everybody. So properties of matter waves. Right? So there are nearly 7 properties. The first property says that lighter is the particle, greater is the wavelength associated with it. Right? Now the second one says that if velocity of particle is smaller is the velocity of particle, greater is the wavelength associated with it. If particle is lighter, it has greater wavelength. If velocity is smaller, it has greater wavelength associated with it. So already we discussed that matter waves are nothing but a moving particle is associated with a wave. That waves we call it as matter waves, as said by de Broglie. Right? Now here, let us see whether these matter waves are electromagnetic waves or not. So third property, it says that when velocity is 0, wavelength becomes infinity. So in such a case, wave becomes indeterminate. Okay, it becomes indeterminate. Now, if v is equal to infinity velocity, then wavelength will be 0. So now here the wave is determinate and matter waves are generated in this case. Matter waves are generated by motion of particles. So these are generated if particle is charged or uncharged. In both cases these waves are generated. Either particle may be charged or uncharged. But for electromagnetic waves, if particle is charged only, we will get electromagnetic waves. If particle is charged only, we will get electromagnetic waves. Right? But here you see, here either particle is charged or uncharged, we are getting matter waves. So matter waves are not electromagnetic waves. They are some another kind of waves. We can say it is not electromagnetic wave, because either particle is charged or uncharged, these waves we will see. These waves will be associated with the particle. But for electromagnetic waves, the particle must be charged. Right? Now next, the fourth property says that the velocity of matter depends upon velocity of matter, the velocity of matter wave depends upon the velocity of matter particle. Velocity of matter particle. Now here, electromagnetic waves velocity will be constant. The velocity of electromagnetic waves will be constant. But here the velocity of these matter waves will not be constant. The velocity of these matter waves will not be constant. It is not constant. But electromagnetic waves velocity will be constant. Now the fifth property says that the velocity of matter wave is greater than velocity of light. The velocity of matter wave is greater than velocity of light. Right? Now let us see whether this statement is correct or not. What we are saying? Velocity of matter wave is greater than velocity of light, it is said. Let us see whether it is right or wrong. So for that, we know that the velocity of photon is h nu, and Einstein's theory says E equal to mc square. So comparing these two, we get h nu equal to mc square or nu equal to mc square by h, right? Now wave velocity. Now what, let us indicate with W. It is nothing but frequency into wavelength. Okay. So frequency into wavelength. Velocity equal to frequency into wavelength. What is frequency? Mc square by h. What is lambda? The de Broglie's wavelength, h by mv. V, h, mm strikes off. So W becomes c square by v. So here wave velocity W, what we got? C square divided by v. Okay. So where v, we call it as particle velocity. We call it as particle velocity. Now here no particle can exceed or will have velocity more than light velocity. We know that particle velocity cannot exceed light velocity. Okay. Hence, from this, as we cannot exceed this light velocity, from this equation we can say that W is greater than velocity of light. Here c square divided by v we got, and v never exceed c. So W will be more compared to this c square by v fraction. So W will be greater than c. So that is, the velocity of matter wave will be greater than velocity of light. Okay, clear? So here v cannot exceed c. So if we do the calculation, the value of W will be greater than c square by v fraction. So W will be greater than c. Right? Now next, the sixth property says that the wave and particle of moving bodies can never appear together. Already in my last video what I said, simultaneously we cannot find the particle as well as wave nature of a particle. So now if particles have wave-like properties, here we cannot find particle nature. If they have, the waves have particle-like properties and particles have wave-like properties. Now particles will have wave-like properties and waves will have particle-like properties. And these two concepts are separately linked. Okay, but matter waves have dual nature. Okay, particles will have wave-like properties, wave will have particle-like properties, means it is having dual nature, and these are separately linked. If one we see, other we cannot find. In such a way, these will be. Okay, now the last property says that it introduces an uncertainty in location of position of particle. Why it creates uncertainty? Why it creates uncertainty means wave, it cannot be said exactly it is at this point or that point. Wave cannot be said exactly that it lies at this point or that point. Right? So only we see uncertainty in location of position of particle. But however, if wave is large, means if it is strong, there is good chance of finding the particle. Okay, if wave is weak or small, there are very small chances of finding the particles. There is very small chances of finding the particles. So these are the 7 properties of matter waves. Thank you.